Welcome to the Explainer. Today, we're doing something pretty wild. We're taking the Flipper Zero, that awesome little pocket-sized multi-tool, and we're giving it an AI brain. Yep, we're turning it into a smart, automated hacking device. Let's jump right in.
So let's start with a big what if, right? What if your Flipper Zero could have a powerful large language model running on it? Imagine just talking to it in plain English. Hey, scan for vulnerable devices, or go capture that network's traffic, and it just does it. Well, that's not some sci-fi dream. That's what we're building today. Now, let's be real. The Flipper itself can't run a modern AI. Its processor would probably melt. So this is all about a partnership. Think of the Flipper as the hands and face. It's the interface, the screen, the power source. But the Rootkit Labs Blackhat board, that's the brain. It's a full-on Linux computer that does all the heavy lifting.
So here's our game plan. First, we'll talk about the concept, then get into the nitty-gritty of how it all works together. We'll walk through the actual installation, then we'll make sure it's permanent. After that, we'll share some pro tips to keep it running smoothly, and finally, we'll unleash it on a real-world hack to show you what this thing can really do.
Okay, let's really dig into this concept. We're exploring what happens when you smash together the Flipper's incredible hardware versatility with the, cognitive power of an AI. This is about making pen testing tools way more accessible and a whole lot more powerful.
So how does this whole setup actually work under the hood? How do these two separate devices team up and talk to the outside world to become this single cohesive unit? Let's break it down.
It really breaks down into three key parts. You've got the Blackhat board, which is the powerhouse, right? It's running Linux and our AI ClawdBot. Then there's the Flipper, which is basically its life support, providing power and a physical interface. And your remote control? That's just your phone, using an app like Telegram to send commands over Wi-Fi. You can control your AI from literally anywhere.
All right, enough talk. Let's get to the fun part. It's time to get our hands dirty, install the core software, and actually bring this AI to life on the hardware.
The installation is actually way simpler than you might think. First, you just prep the Blackhat's operating system, making sure it's got the right version of Node.js. Second, you run one single script to install ClawdBot. Third, a little onboarding wizard pops up to help you connect your AI model and your Telegram bot. And finally, you give the AI shell access, basically handing it the keys to the whole system.
Okay, hold on. Before we go any further, there are a few really critical things to keep in mind. First, this thing is a battery hog. It'll drain your Flipper fast. More importantly, let's talk security. ClawdBot has zero guardrails and full root access to the system. You are literally giving an AI complete control, so make sure you secure it properly. And of course, make sure its Wi-Fi is working, otherwise it can't talk to its AI brain on the internet.
Having to manually SSH in and start the AI every single time you boot up the device, that's a huge pain. So now, we're going to refine the setup and make our AI a permanent automated part of the system.
And for that, we're going to use something called a systemd service. It's the professional way to manage background processes in Linux. All it does, really, is you create a little rule that tells the operating system, hey, every single time you boot up, run this AI. No more manual startups. Set it and forget it.
Now, this little service file you see on the screen, this is where the magic happens. Look at that line that says after equals networkonline.target. That's super important. It tells the AI, hey, don't even try to start until you have a solid internet connection. And restart equals always? That's your safety net. If the AI agent ever crashes for any reason, systemd will just automatically restart it for you. It's a really robust setup.
And then, bam! These four simple commands make it official. You tell the system manager to reload, you enable the service so it starts on boot, you start it right now, and then you just check the status to make sure everything's running smoothly. That's it. You're done.
To get that remote control working from your phone, we've got to hook it up to Telegram. It's a quick three-step process. You get an API token from something called BotFather, you grab your unique chat ID so that only you can send it commands, and then you just plug those two details into the ClawdBot config. Now it's locked down and tied directly to your account.
So our AI is up, it's running permanently. But now we've got to talk about keeping it healthy. We need to make sure the hardware can actually keep up with what the AI is demanding, especially when it's doing something really intensive.
See, the Blackhat board's RAM is pretty limited. To stop the AI from crashing when it's thinking really hard, we're going to create what's called a swap file. This is a classic Linux trick. You basically section off a piece of your micro SD card and tell the system, hey, you can use this as extra emergency RAM. When the real memory gets full, it just offloads stuff to the SD card. It's a lifesaver.
And creating this swap file is a super simple 5-step process. You can see it here. You allocate the space, set the right permissions so the system can use it, format it as swap, turn it on, and then, most importantly, you add it to the fstab file. That last step, make sure it's turned on every single time you boot up.
And listen, this is a huge pro tip, so please don't skip this. Using a swap file means your system is constantly reading and writing to that microSD card. A cheap, standard card will wear out and die really quickly, and it could even corrupt your whole operating system. Do yourself a favor and invest in a good, high-endurance card. You will thank yourself later.
All right, time for the payoff. We've done all the setup, we've optimized the performance. Now let's put our new AI to work and automate a classic Blackhat task, capturing a Wi-Fi handshake.
So first, we whip up a simple Python script on the Blackhat board. This script is going to be our AI's new favorite tool. All it does is automate the boring stuff. It takes the Wi-Fi card, uses airmon_ng to pop it into monitor mode, and then uses arrowdump_ng to start sniffing a specific network, just waiting for that handshake.
And this is where it all comes together. This is the magic of having an AI. We don't have to remember long commands or SSH into a terminal anymore. We just teach the AI a shortcut in plain English. We say, hey, whenever I say capture followed by a network name, I want you to run that script for me. It's that easy.
And the result? An incredibly simple workflow. Imagine you're out in the field. You just pull out your phone, open Telegram, and type capture guest_network. And just like that, the AI on your Flipper instantly gets to work and messages you back to confirm the attack is underway.
Okay, one last but really important hardware note for this specific hack. The Blackhat board needs its built-in Wi-Fi to talk to the internet so the AI model can function. That means you can't use that same Wi-Fi chip for the attack, so you'll need a second little USB Wi-Fi adapter plugged in, one for talking and one for hacking.
And there you have it, a Flipper Zero with an AI brain. It's a true next-generation tool. We've automated a handshake capture today, but that's just scratching the surface. Think about what's next. Automating Bluetooth scans, RFID analysis, running custom scripts. The possibilities are endless. So, the real question is, now that your Flipper is supercharged, what are you going to automate next?